Credit card fraud has become a significant issue in the digital age, with a huge amount of money lost annually due to fraudulent transactions. Banks and financial institutions are forced to deploy fraud detection systems to mitigate these risks. This paper presents a novel approach using Asexual Reproduction Optimization, ARO, to detect credit card frauds. ARO is a supervised method that aims to improve the effectiveness of fraud detection by sampling from the majority class, thereby enhancing recall and reducing the required training time. The paper highlights the importance of fraud detection systems, which can be categorized into expert-driven, data-driven, or a combination of both. Data-driven methods, such as machine learning techniques, have been increasingly used to learn fraud patterns and identify them in data streams. However, many of these methods require a time-consuming training phase, which limits their applicability. The proposed ARO method addresses this limitation by providing an efficient way to detect fraud without requiring extensive training time. The authors applied this method on a publicly available dataset and compared it with artificial immune systems, ICE, one of the best methods implemented on current datasets. The results show that ARO achieves the best cost in a short time, making it suitable for real-time fraud detection systems. Credit card fraud can be categorized into application frauds and behavioral frauds. Application frauds involve getting a new credit card using wrong information, while behavioral frauds involve fraudulent activities when the cardholder is not present. As the number of frauds increases, fighting techniques against fraud become more significant. Prevention and detection systems are the first and second layers to protect the system against fraud, respectively. The paper also discusses the growth of fraudulent activities with the increase in credit card transactions, emphasizing the need for an effective fraud detection system. This system should identify a high percentage of fraudulent transactions while keeping the false alarm rate low to avoid user apathy. By implementing different data mining techniques and acknowledging the development of data mining methods, efficient ways have been found to detect fraud. However, the proposed ARO method stands out for its ability to provide accurate results in a shorter time frame compared to other machine learning techniques. The paper discusses credit card fraud detection using Asexual Reproduction Optimization, ARO. It begins with a literature review on various methods, including supervised, unsupervised, and semi-supervised algorithms. Table 1 lists several data mining approaches used for fraud detection. The ARO model is then presented, focusing on artificial immune systems, ICE, for faster and more accurate detection compared to other state-of-the-art methods. The paper also reviews various techniques such as neural networks, support vector machines, decision trees, and random forests, highlighting their strengths and limitations. Experimental results and analyses are presented, followed by a conclusion and suggestions for future research directions. The summary covers key terms, methodologies, and significant findings from both pages, ensuring technical accuracy and clarity for expert audiences. Credit card fraud detection is a critical issue in financial institutions, where the primary goal is to increase accuracy, reduce detection time, and lower costs. Various algorithms have been proposed to address this problem, but most have limitations in terms of speed, accuracy, and cost. A comparison of algorithms, including neural networks, NN, Bayesian networks, BN, support vector machines, SVM, k-nearest neighbors, KNN, decision trees, DT, fuzzy logic, artificial immune system, ICE, genetic algorithms, GA, and hidden Markov models, HMM, reveals that ICE performs the best overall. This paper proposes the use of Asexual Reproduction Optimization, ARO, for credit card fraud detection. ARO is a supervised method that has several advantages over other algorithms, including faster convergence, good exploration and exploitation rates, and no requirement for parameter settings. ARO is also a free model algorithm that can be applied to various types of optimization. The paper explains the implementation of ARO for fraud detection, where the data is separated into training and validation parts. The ARO algorithm is inspired by the budding method of asexual reproduction, where a parent produces a smaller copy of itself called a bud. The bud is then mutated and evaluated using a fitting function. The fitting function is calculated using equations 1 and 2, which measure the distance between the normal and fraudulent transactions. The cut point is the best fitness achieved in the dataset. The mutation process is repeated until the parent fit is smaller than the cut point. The probability of mutation is calculated using equation 3, and the bud is mutated based on this probability. The value of the mutated bud is calculated using equation 4, which evaluates the fitness of the bud. The arrow algorithm is compared with ICE, which has the highest performance among the existing algorithms. The results show that arrow outperforms ICE in terms of speed, accuracy, and cost. Overall, arrow is a promising approach for credit card fraud detection, offering a faster and more accurate solution than existing algorithms. Here is the combined summary of pages 7 and 8. The Asexual Reproduction Optimization (ARO) algorithm is employed for credit card fraud detection. The algorithm's fitting calculation involves separate bud fits for the fraudulent and legal matrices, with the bud replacing the parent if its fitness is superior. The loop termination condition is reached when the parent fit is compared to the cut point. The distance record is calculated as the maximum difference between the fraudulent transactions and normal transactions, normalized by the parent fit. The ARO algorithm is schematically represented in Figure 1, where an individual is denoted by a vector of variables x, comprising chromosomes represented as binary strings of length L. The algorithm initiates with a random individual in the solution scope, which reproduces an offspring called a bud. The fittest individual, either the parent or bud, survives, and the process recurs until the stop condition is met. In the reproduction stage, a larva is created by selecting a substring of lambda bits from all chromosomes, which is then mutated in the exploration phase. The parent and larva merge in the exploitation phase, with the bud gene being picked from the larva if p, calculated from equation 6, is higher than 0.5, otherwise, it is picked from the parent chromosome. The fitness of both bud and parent is calculated to choose the best one for the next iteration. The algorithm is applied to all records and features, with each record having a fraud or normal label. Notably, only the integer part of the chromosome is considered, and genes are not binary, containing integer numbers. The normal records are sampled, as the dataset is skewed towards normal transactions, and the number of normal transactions is significantly more than fraudulent transactions. Credit card fraud detection using Asexual Reproduction Optimization and Artificial Immune System (ICE) algorithms are two distinct approaches to identify fraudulent transactions in a dataset. The ARO algorithm uses an asexual reproduction process, where a parent generates a bud, which then undergoes a process of larva generation and selection. This process is repeated until a suitable normal sample is identified, with the fitness function evaluating the distance between the record and both fraud and normal transactions. The higher the fitness number, the better the record, as it indicates closeness to normal transactions and distance from fraud ones. On the other hand, the ICE algorithm draws inspiration from the human immune system, employing negative and clonal selection stages to create detectors called lymphocytes. These detectors react to non-self cells, such as viruses, and protect the body against them. In the context of credit card fraud detection, both non-self and self cells are considered vectors, and the training set is normalized before initializing parameters. Primary detectors are selected randomly from normal records, and their affinity is calculated using a distance function. A colony is expanded from these detectors, mutated, and the best mutated population is chosen to replicate the worst memory cells. This loop continues until a stop condition occurs, such as after 150 iterations. In terms of experimental settings, the dataset used for this study is described, followed by details on the experimental setup. The results are presented based on metrics discussed in the paper, providing insights into the effectiveness of both ARO and ICE algorithms in detecting credit card fraud. These algorithms aim to improve fraud detection accuracy and efficiency, offering a new perspective on how to tackle this complex problem in the financial sector. The research focuses on credit card fraud detection using Asexual Reproduction Optimization (ARO) and Artificial Immune System (ICE) methods. The dataset used is from a Brazilian bank, with 3.74% of transactions being fraudulent. The dataset was split into 9 parts for training and testing. The fraud detection system was trained using both ARO and ICE methods, and the performance was evaluated using metrics such as sensitivity, precision, specificity, and accuracy. The results show that ARO outperforms ICE in terms of sensitivity, precision, specificity, and accuracy, with a significant increase in the area under the curve, AUC, of the ROC curve. Additionally, statistical tests were conducted to ensure the statistical significance of the results. The findings suggest that ARO is more effective for credit card fraud detection compared to ICE, particularly in terms of accuracy and AUC. This research paper presents a comparative analysis of two bio-inspired algorithms, Asexual Reproduction Optimization, ARO, and Artificial Immune System, ICE, for detecting credit card fraud. The study utilized a dataset from a Brazilian bank, which contains both fraudulent and legitimate transactions. The evaluation metrics include sensitivity, precision, specificity, accuracy, and area under the receiver operating characteristic curve, AUC. The results indicate that ARO outperforms ICE in all the metrics, with an average sensitivity of 0.81 and precision of 0.39, compared to 0.65 and 0.25 for ICE. Moreover, ARO demonstrates a significantly shorter training time, averaging 6.25 seconds, making it more suitable for real-time fraud detection systems. The cost function used in the study is based on an average cost of $1 for every verification and an average loss of $100 for every undetected fraud, as proposed by Gotti et al. This function aims to simulate practical scenarios where the cost of undetected fraud is significantly higher than the cost of verification. The receiver operating characteristic, ROC, curve was plotted to evaluate the performance of the algorithms. The ROC curve helps in identifying the cutoff value, which is the point where sensitivity and specificity are equal. This value is crucial in determining the threshold for classifying transactions as fraudulent or legitimate. The study also highlights the limitations of the ICE method, particularly its need for hyperparameter tuning, which is not required in ARO. This makes ARO a more efficient and practical choice for fraud detection systems. In conclusion, the study demonstrates the potential of ARO in enhancing the efficiency and effectiveness of credit card fraud detection systems. The findings suggest that ARO could be a promising alternative to traditional methods, offering better performance and faster processing times. The research paper discusses the application of Asexual Reproduction Optimization, ARO, in credit card fraud detection, comparing its performance with other methods. ARO improved sensitivity by 25%, precision by 56%, and decreased cost by 41%, with a training time reduction of 75%. The results are statistically significant, as demonstrated by Wilcoxon and Kruskal-Wallis tests. The ARO algorithm outperforms ICE, a previously best-performing method on the dataset, in terms of accuracy, specificity, and training time. The study suggests future improvements, such as employing cloud computing and exploring deep learning methods to further enhance performance. The ARO approach is particularly effective due to its individually based optimization, good exploration and exploitation rates, and lack of parameter settings, making it suitable for real-time fraud detection systems. The proposed framework for credit card fraud detection using Asexual Reproduction Optimization, ARO, has addressed the issues of high costs and training time. However, there is still room for further improvement. Future work includes testing the proposed model in a cloud environment, such as Hadoop, to increase performance. Additionally, ARO can be compared to particle swarm optimization, PSEO, and quantum-behaved particle swarm optimization, QPSO, which have fewer parameter settings than artificial immune systems, ICE. The writers believe ARO has the potential to obtain better results. One potential improvement is to weight the fields that compose a transaction, as some fields are more important than others. The distance function can also be different for each property in the dataset, considering application-based distance functions for each field. The paper provides a comprehensive review of existing literature on credit card fraud detection, citing 33 references that employ various techniques, including artificial immune systems, generative adversarial networks, sequence classification, hybrid approaches, and machine learning algorithms. These references highlight the significance of credit card fraud detection and the need for effective methods to combat this issue. The authors suggest that ARO can be a promising approach for credit card fraud detection, given its ability to adapt to changing patterns and trends in transaction data. However, the framework requires further refinement and testing to ensure its effectiveness in real-world scenarios. By addressing the limitations and exploring new avenues for improvement, the proposed framework can contribute to the development of more accurate and efficient credit card fraud detection systems. Here is a combined summary of pages 19 and 20. Credit card fraud detection has been an active area of research, with various machine learning and optimization techniques being employed to combat this issue. Numerous studies have utilized classification algorithms, such as Bayesian networks, neural networks, and decision trees, to detect fraudulent transactions. Other approaches have involved the use of optimization techniques, including asexual reproduction optimization, to improve the accuracy of fraud detection models. Several studies have also focused on the application of machine learning algorithms, such as support vector machines, random forests, and artificial immune systems, to credit card fraud detection. These algorithms have been shown to be effective in identifying fraudulent transactions, with some studies achieving high detection rates. In addition, researchers have explored the use of ensemble methods, such as bagging and boosting, to combine the predictions of multiple models and improve the accuracy of fraud detection. Other approaches have involved the use of feature selection methods to identify the most relevant transaction features for fraud detection. The literature review highlights the diversity of techniques that have been employed in credit card fraud detection, including the use of artificial neural networks, logistic regression, and Dempster-Shafer theory. The studies reviewed demonstrate the potential of machine learning and optimization techniques in improving the accuracy and efficiency of fraud detection systems. Furthermore, the review emphasizes the importance of evaluating the performance of fraud detection models using metrics such as accuracy, precision, and recall, as well as the need for robust feature engineering and data pre-processing techniques to ensure the effectiveness of these models. Overall, the studies reviewed demonstrate the ongoing efforts to develop more accurate and efficient credit card fraud detection systems, and highlight the potential of machine learning and optimization techniques in addressing this complex problem. Here is a combined summary of pages 21 and 22 of the research paper. The authors present a comprehensive review of existing literature on credit card fraud detection using various machine learning and optimization techniques. The surveyed papers employ different approaches, including artificial neural networks, genetic algorithms, support vector machines, and hybrid models. The authors highlight the importance of feature engineering and optimization techniques in improving the accuracy of fraud detection models. Several papers utilize neural networks, including convolutional neural networks, recurrent neural networks, and deep neural networks, to detect credit card fraud. These models are often combined with optimization algorithms, such as genetic algorithms, simulated annealing, and particle swarm optimization, to optimize the model parameters. Other approaches include the use of hybrid models, such as neurofuzzy systems, and ensemble methods, like bagging and boosting. The authors also discuss the application of evolutionary algorithms, like asexual reproduction optimization, to credit card fraud detection. Additionally, they review papers that employ clustering algorithms, like k-means and hierarchical clustering, to identify fraudulent patterns. The surveyed papers demonstrate the effectiveness of machine learning and optimization techniques in credit card fraud detection, achieving high accuracy rates and reducing false positives. However, the authors also highlight the limitations and challenges of these approaches, including the need for large datasets, the risk of overfitting, and the importance of feature engineering. The review provides a comprehensive overview of the existing literature on credit card fraud detection, highlighting the strengths and weaknesses of various approaches and identifying areas for future research. The authors emphasize the need for continued innovation and development of more accurate and efficient fraud detection models to combat the growing threat of credit card fraud. The research paper discusses the application of asexual reproduction optimization in credit card fraud detection. It highlights various studies and their contributions to the field, including probabilistic credit card fraud detection systems, hidden Markov model-based approaches, and game theory-based methods. The authors emphasize the importance of optimizing fraud detection systems to improve accuracy and efficiency. They also discuss the limitations of current methods and the need for further research in this area. The paper concludes by highlighting the potential of asexual reproduction optimization in enhancing the performance of fraud detection systems.